This is video 2 in week 11. Now we consider a scatter plot smoother for a dataset xi, yi. I can be 1 until n. This is the dot point. For example, in the graph, the x is the x-axis and y is the value for the y-axis, and the dataset xi, yi are represented by the circle point, Remember, corresponding to our crude rate, the xi is the age and the yi is the crude death rate or crude mortality rate. Because I introduced the smooth techniques in a general perspective, students, please be careful here that you can understand this section explicitly by looking xi as age, yi as the crude rate. So given xi, yi, or given the circle point in this plot, our task is to find a smooth curve that can be used to represent this circle point as accurately as possible. The method of searching for this smooth curve in this section is called the smooth. Okay. Now I introduce a parameter. It is called lambda. It is called the smooth parameter, and it controls the trade-off between the smoothness and the fidelity. The fidelity here can be understood as the goodness of fit. Remember, in the lecture of the graduation, I explained that the smooth curve, a better smooth curve, should balance well between the smoothness of the curve itself and the goodness of fit, right? And here I introduce a lambda, the smooth curve, that is control this balance. And for given smoothness, for given smooth value lambda, a better smooth curve is represented by Sx given lambda, because the lambda controls this smoothness and goodness of fit. So we use the lambda as the parameter in this smooth curve, and x here is the value for the x-axis. Now the question here becomes optimization problems, that is to find out the minimizer, because we firstly have to find out the optimal smooth lambda. So this optimal parameter value can be found out by minimizing this objective function. This is e to the power of, the objective function is represented by the e to the power of lambda. That is the explanation of the y minus this smooth curve. Smooth curve is represented mathematically by using s x given lambda. So we want the explanation of the square as small as possible. So we have to find so the optimizer smooth parameter lambda is the value such that this explanation is the minimum. The explanation is respective to x and y, so this is explanation for this joint random variable.